All right. Today we're on day 5 of ACT Prep Unit 2, Pre-Algebra 2 topics. And today we're talking about data collection, representation, and interpretation. So your ACT test items are going to ask you to read and interpret tables and graphs, not to create it. We're going to create some just because it's going to help you understand how they're made and how to read them better. But you won't actually have to create them on an actual ACT test. Graphs and charts help us read and interpret data. This section is going to review bar graphs, line graphs, circle graphs, stem and leaf, and box and whisker. Okay, so the table below shows the number of new cars a dealer sold over 6 months. A bar graph of this information, they put the April, May, June, July, August, September on the y-axis, and they put the number of new cars sold on the x-axis. I actually would have done it different. I would have put my April, May, June, July, blah, 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 and I'd have put my 0, 10, 20, 30, 40, 50 here. And you could do that either way, okay? But the point is, you take whichever way you're doing it. So for me, for April, I would come up to 30, and I would go bloop, 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 and there's my bar graph for April. For May, it was up to 45. So that would come up to about right there. In June, there was 37, so that would come up to about right there. In July, there was 34, so about right there. And then what we have, August and September. August was 29, and September was 35. That's how I would have made the bar graph. They did the exact same thing. They just switched axes. They put the months over here and the number of cars sold on the bottom. So it's kind of interesting to see. I don't see them this way very often. But they did the same thing. For April, they came over here to 30. They just are going sideways instead of up and down. May went to 45, June went to 37, July went to 34, August went to 29, September went to 35. There's your bar graph. All right, a line graph. They did the exact same thing, except for this time they did actually put the months on the bottom and the new cars sold on the y-axis. And then for April, you put a dot for 30. May, you go up to 45. June, down to 37, July to 34, August to 29, and September to 35, and then you connect the dots. That's a line graph. Okay? A circle graph. A circle graph is used to show relative size, usually with percents. You can use a circle graph for data that can be categorized. So it says Jason brings home $1,000 a month. His budget is shown below. He spends $300 on rent, $250 on food, $100 on gas, $150 on recreation, $120 on savings, and $80 on miscellaneous. So how in the world did they come up with these percentages from these numbers? Well, you're trying to figure out what percent of 1,000 is 300. So what you're going to do is you're going to say 300 divided by 1,000, okay, is 0.3. Turn it into a percent, makes it 30%. So that's how they got their rent, was 30%. They did the same thing for food. 250 divided by 1,000 is 0.25, so that's 25%. Gas, 100 divided by 1,000 is 0.1, as a percent is 10%. Excuse me, recreation, 150 divided by 1,000 is 0.15, so that's 15%. Savings, 120 divided by 1,000 is 0.12, so that's 12%. And then 80 divided by 1,000 is 0.08, 2 places over makes that 8%. And then you just kind of break your circle up accordingly. 30%, approximately, and they break it up. All right, stem and leaf diagram. A stem and leaf diagram is a way to group data. It says, suppose 20 students received the following scores on a math test. What I do is I like to put them in order just like I was doing mean, median, and mode. So I took all these numbers and I put them in order, starting with the smallest and went up to the biggest, okay? Then what you do is you have numbers in the 60s, 70s, 80s, 90s, and hundreds. So your stems are going to be that tens place. So there's your 6D, there's your 70s, there's your numbers in the 80s, there's your number in the 90s, and there's your number in the hundreds. So there's my stems, and then you just literally put the leaves. For 6, there's 63, 65, 68. My 70s, there's 72, 72, 74, 75, 78, 79. My 80s, 83, 85, 86, 89. My 90s, 94, 95, 97, 99. And my hundreds, 100, 100, 100. There's your stem and leaf plat. Okay? It says the values in the stem represent tens, while the values in the leaves represent ones. We can easily tell from this diagram that there are 3 scores of 100. Alright, a box and whisker plot. A box and whisker plot shows the median and quartiles of a set of scores, along with the maximum score and the minimum score. It says use the data in the stem and leaf plot above. So I copied the data from the last set of data that they gave me. And you look for these things, okay? I need to find a minimum, I need to find a maximum, I need to find a first quartile, a median, which is also sometimes called the second quartile, and the third quartile. So let me tell you how they found those. Well, obviously the minimum is easy, and the maximum is easy. Okay, and so what they do is on a number line, they plot the minimum and the maximum on the number line. And then what I do is, before I even add those other dots, I make a straight line and connect them, because I'm going to put my other dots on them. Alright, the median, we put them in order, and sorry, I didn't animate that, I was checking. So we find the median, bloop, 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 bloop. You like my sound effects? And it's a tie between those two. So I add those up and I divide by 2 and I get 84. Okay, so there's my median. I put that dot on there. Okay. Then what you do is, that breaks it, since there was a tie, that will divide my data into 2. This would be the first half and this would be the second half. So basically I've cut my data in halves. Then basically what you do to get your quartiles is you cut your data into quarters. So I need half of this data. So bloop, 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 bloop. And it's a tie between 72 and 74. So I add those up and divide by 2 and I get 73 is right there. There's your first quartile. Again, the median, this is also called Q1. Okay, median is often called Q2. And your third quartile is called Q3. Okay, so to get my third quartile, I cut my upper half in half. So bloop, 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 and it's a tie between 95 and 97. So add those up, divide by 2, and you get 96. So there's my third quartile. And then all you do, you draw the line through them, and then you make your box, and your box goes from the first quartile to the third quartile, and then you put that little line in the middle. And there's your box, and these are your whiskers. Okay? And what it does is it cuts your data up into quarters. Okay? 25% of your data is in this section. 25% more is in this section. 25% more is in this section. And 25% more is up above here. There's 100% of your data cut up into quarters. Okay? So, you try this one. Hit pause. Come back when you're ready. And hopefully you got C. Alright, if I was doing this, I would, see we have numbers in the ones, which means the tens digit would be 0. We have numbers in the tens, which means the stem would be 1. And we have numbers in the 20s, which means the stem would be 2. And again, I put them in order for you just to save time. Alright, so your ones is 0, 3, 0, 5, 6, 6, 8, 9, and 9. In your tens, I have a 10, a 12, a 12, a 14, a 14, a 15, and a 17. And in my 20s, I have a 20, 21, 22, 23, 25, and 29. And that's the one that matches it. Okay? The weights in kilograms of 20 students are given below. One says use the data to create a stem and leaf diagram. So what you do is I put them in order from smallest to biggest, and I made my little stem, and here's my stem and here's my leaves. Alright, I have numbers in the 40s, the 50s, the 60s, the 70s, and the 80s. My numbers in the 40s are 43, 47, 48. My numbers in the 50s are 53, 55, 56, 57, and 58. 60s is 60, 61, 62. 70s, 71, 72, 75, 76, 79. And in the 80s, 81, 82, 84, and 88. And there's my stem and leaf. Oh, and then you need a key. So you pick anything. I usually just pick the first, like here, this stem and this leaf, and you say 4 bar 3, meaning stem and leaf, means to read 43. Okay. Alright. Same data, and now they want me to create a box and whisker plot. So I copied my data again. Alright, and then what you're going to do is I find the middle. So I bloop, 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 you know, and look, I highlighted them, so I did it. So it was a tie between 61 and 62. So I divide by 2. So my median, well, dang, I was going to write them all down, but sorry. Okay, so my median, because remember, we need a min, we need a max, we need Q1, Q2, Q3. Q2 is the median. So my median is 61.5. Okay, so that cuts my data in half. So next, to get my quartiles, okay, I split the data, and I put this half here, and I put this half here, and you do it again. Okay, so in the middle, I've got a tie between these two, so I add them up, divide by 2, and my first quartile then is 55.5. Okay, my Q3, quartile 3, I split the upper data, so I put that in order, and there was a tie between 76 and 79, so that gives me a Q3 of 77.5. My minimum is obviously 43, my maximum is obviously 88. So once you have all that data, my minimum was 43, my maximum was 88, my Q1 was 55.5, Q2 was 61.5, and Q3 was 77.5. So now we're going to draw our box and whisker plot. So I make a number line, and you plot these points. 43 is about right there. I do my min and my max. 88 is about right there. Why I put commas there, I have no idea. And then, like I said, I like to go ahead and draw that line connecting them, because then you know where to put your dots. It's easier to line everything up. Alright, so there's my min and max. Then you add your quartiles. My Q1 is 55.5, which we'll say is about right there. My median, or Q2, is 61.5. We'll call that about right there. And my Q3 is 77.5, which is about right there. And my box goes around the 3 in the middle. And you put your line right there. Okay? That would be my box and whisker plot. Alright. This one says, given below is the amount of money Chad spent on his car from April through August. 3 wants me to create a bar graph. So like I said, I like to put I always put time on the x-axis because it's the independent variable, but so I put April here, then I have May, then I have June, July, and August. And my data goes from $100 to up to $175. So what I do is I put a little jag in here, jig jag in here, because we don't have any data from 0 to 100. So I'm going to start at 50. Okay, and then I'm going to count by 25. So that would be 75, 100, 125, 150, 175, 200. And whether you're making a bar graph or a line graph, this part looks the same. I mean, you could switch it, I guess, but I don't know why you would. So April, May, June, July, August. And again, make your little doohickey and go, there's 50, and then I'm going to count by 25, 75, 100, 125, 150, 175, 200. Okay? So whether you're doing a bar graph or a line graph, you label your axes the same way. For a bar graph, in April, you come up to 100. May, you go up to 125. June is 175. July is 150. And August was 125. And then you color them in. There's my bar graph, which I'm very lazy to color. Your line graph, you do the same thing, but instead of making bars, you make dots. So I've got 100, oops, right there, 100 in April. In May, I've got 125. June, I've got 175. July, I've got 150. In August, I've got 125. And then you connect the dots. And that would be my line graph. Okay. Alright, same thing but different data, and they want me to create a line graph and then a bar graph. So Roman is a car salesman. Given below are the number of cars Roman sold during a 6-month period. So I'm going to do month 1, 2, 3, 4, 5, 6. First month, second month, third month, fourth month, fifth month, sixth month. And my cars. So the lowest amount I have is 9. The highest amount I have is 14. So I think I'll count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. Two, 4, 6, 8, 10, 12, 14, 16. Alright, so the first one we're doing is a line graph. So in month 1, he sold 13 cars. That's going to be about right there. In month 2, he sold 10. In month 3, he sold 14. In month 4, he sold 12. In month 5, he sold 9. And in month 6, he sold 12. So connect the dots. Not that dot. And there's my line graph. My bar graph, same thing, but you draw bars. So in month 1, we went up to 13 cars. In month 2, he sold 10. In month 3, he sold 14. In month 4, he sold 12. In month 5, he sold 9. Where are you going? In month 6, he sold 12. What was 5? 9 cars? I went past everything. Alright, and then we fill them in. And that would be your pretty bar graph. Alright. It says, using the stem and leaf diagram below, write the values for the minimum, first quartile, median, third quartile, and maximum. So the first thing I do is I list my numbers in order. 1, 3, 12, 15, 17, 21, 24, 26, you get it. All the way up to 59. So my min, my min is going to, well, I'll do it up here because I don't remember what it was. My minimum is going to be 1. My maximum is going to be 59. You can see I color coded it. 33 is in the middle, so I need Q1, Q2, and Q3. Q2 is 33. Now, before there was a tie. That one is the splitter. Since it wasn't a tie, 33 is now out of the data. So to get my Q1 and Q3, Q1 I'm going to look at this half, and Q3 I'm going to look at this half. So I put these, and I found the middle. So there's my Q1 is 21. And I did the other half, and the middle is 42. So Q3 is 42. So my minimum is 1, maximum is 59, Q1 is 21, Q2 is 33, Q3 is 42. So I get myself a little number line. Alright, I have my minimum is 1, my maximum is 59, and again I draw my line so I can kind of keep things straight here. Okay, and then I add my quartiles. My Q1 is 21, about right there. Median is 33, about right there. Q3 is 42, about right there. And you draw your box. And there you go. And there's your box and lister. Alright, below is a bar graph comparing the number of miles 5 friends jog each week. Who jogs the second farthest? Well, this guy's the farthest. So the next highest bar, which is this guy, so Chrissy is the one who traveled the second farthest each week. Okay, 10, the circle graph below displays the amount of time Danielle spends doing specific activity each day. On which activity does Danielle spend the least amount of time? So we're looking for the smallest wedge, which is the stripes, which is exercises. Me too. Huh. Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 97. Darn it. Hopefully you got 97. Okay, so what you do is, this is 90. It says, during an August heat wave, Wendy kept track of the high temperature every day for a week. She graphed her results on a line graph. To the nearest degree, what was the average high temperature that week? Average means add them up and divide by the number of numbers. So we have 90, this is 85, this is 95, 100, 100, 110, and 100. So I add all those up, and there's 7 days. So I divide by 7, and I get 97.14, blah, 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 blah. And it says to the nearest degree, 1 isn't going to bump it up, so it's 97. Okay? Alright, try this one. Hit pause. Come back when you're ready. And it should be this one, sorry. My arrow was in the wrong spot. I meant to fix that and I forgot. Okay, your answer is J. It says the bar graph below shows the scores on a recent math test. What percentage of the class scored in the 80s or higher? Well, you had 1 student score 60. You have 3 students that scored in the 70s. You have 5 students that scored in the 80s. And you have 3 students that scored in the 90s. And they want 80s or higher, so that's these two. So I have 5 plus 3 divided by the number of kids, which is 1 plus 3 is 4, plus 5 is 9, plus 3 is 12. So I have 8 divided by 12, which is 0.66666. Percentage, make it times 100, move it over 2 places, is 66.6 repeating, and you should just memorize that 0.6 repeating is the same as 2/3. So my answer should be 66 and 2/3. Alright, try this one, hit pause, come back when you're ready. You got to be careful when you read these. I kept thinking that this answer was wrong. It says, which of the following is greater than 75% of the scores shown in the box and Lister plot shown below? Well, you have 25% of your data in the first quartile, 25% in the second, 25% in the third, 25% in the fourth. So greater than 75% would be all of these numbers. Okay, so initially I thought, well, the number is 26. That's the third quartile. But it didn't say what is the third quartile. It wants to know which of the following of these numbers is bigger than 75%. Well, that would be any number bigger than 26. The only number bigger than 26 is 28. Okay? Try this one. Hit pause. Come back when you're ready. And hopefully you got H. Okay? It says a store manager receives hourly updates about the sales in cash registers throughout the store. The stem and leaf display below shows the sales from the most recent hour. What is the median sale? Well, to find the median, you have to put them order from smallest to big. And really, you can do it in the stem and leaf plot. Smallest, biggest, smallest. Then you knock this one off, that and that. Next and next, next and next, next and next. Next and next, 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 and you get that one. Oops. Yeah, see, that's why I don't do it like that. I ended up with the wrong two numbers. When I did it, put it in order, I get these. There was a tie in the middle, so I add them up and divide by 2, and I get 143.5. What did I do there? See how I mess up, so that's why I just put them in order. But again, on an ACT, it takes a long time to write all those out in order. Let's see what I screwed up. Smallest, biggest, smallest, biggest, smallest, biggest, small, big, small, big, small, big, small, big, small, big, small, big, small, big. Huh. I got 144 and 145. I don't know what I'm messing up here. 105, 105, 108, 112, 15, 17, 21, 24, 27, 28, 43, 43, 44, 45, 51, 52, 54, 58, 60, 82, 83, 89, 86. Trying to see if I screwed up here. Thought I checked the answer in the book. No, it's right. I don't know what's going on right here. I don't know why I'm coming up funny there. Yeah, my suggestion is write the numbers out. Alright. Try this one. Hit pause. Come back when you're ready. And hopefully you got 8. So it says Alex likes to eat salads for lunch. Alex makes his salads with lettuce, tomatoes, onion, mushroom, and peppers. It says he uses 2 times as many mushrooms as peppers. So let's say he uses X peppers. Then the amount of mushrooms is double that. Okay? And then it says the same amount of onions as peppers. So peppers was X, which means onions is X, because they're the same amount. Then it says 3 times as many tomatoes as peppers. So if peppers is X, tomatoes is 3 times that. And 4 times as much lettuce as peppers. If peppers is X, then lettuce is 4X. So what I do is I look at, well, the first thing I notice is that the wedge of the onion and the peppers has to be the same. Well, in this one, those are equal. Onions and peppers here, no, there's more peppers than onions, so that's out. Here, there's way more peppers than onions, that's out. Here, there's way more onions than peppers, so that's out. But here, they're equal also, so it's between A and E now. So what else do I know? Well, I just pick anything. It says that the mushrooms has to be double, the size of the mushroom wedge needs to be double the size of the peppers wedge. Well, if this is peppers, and my mushrooms need to be double that ain't double that. It needs to be twice as big as this wedge. And if you look here, there's peppers, alright? And if I cut this in half, okay, you see how this is double the size of this? So it's got to be 8. Alright, and we are done for today. So, I will see see you for day 6.